I'm Nathan Morris, Farming Systems and Soil Specialist at NIAB TAG, and I just want to give you a brief overview on soil compaction, what it is and how we can manage it by mechanical alleviation with cultivations and what impacts that can have on crop performance. So this is a very good diagrammatic view of what effectively a good soil structure can look like. Nice open structure with open spaces, pore spaces between the soil particles that allows air and water to flow through the profile of the soil. When the soil becomes compacted, whether that's through tillage operations or traffic operations across the field, we effectively condense those particles together, close the pore spaces between, and effectively restrict the flow of air and water through the profile. We also see increased bulk density, so effectively the soil will become stronger and will be harder to cultivate and require greater draft requirements and therefore higher fuel consumption. So there are a number of factors that can influence soil compaction, and obviously probably one of the most important is soil moisture. When we have a dry soil, whatever load we are putting onto that ground, it is spread relatively uniformly to a shallower depth of the soil profile than when the soil becomes wet. That weight transfers much more easily through the profile because the soil is much wetter, it's softer, and it's much more susceptible to transferring that pressure of the machine through the profile. So you get much greater compaction to a greater depth, which obviously has implications on both crop performance and the flow of water through the soil and potentially leading soil erosion. And obviously to alleviate that damage, we have to do some sort of measure of cultivation. Field traffic obviously is probably one of the greatest ways of transferring the compaction to the soil. Particularly at harvest times, at harvest operations, when you can effectively have to go randomly across the field, and that will increase the damage caused to the soil. Potentially, the first pass you do across a field after cultivations, whether that's through inputs to your crop or whether that's at harvest time, that will be the greatest, or have the greatest effect on the soil compaction. Potentially up to 50% can be caused by that first pass. Subsequent passes, we can see, will add a further addition of compaction, but to a lesser degree. Again, trying to restrict your passes to specific tram lines or wheelways across the field will obviously alleviate some of that compaction to known areas where you can potentially do something about it. So when we consider how we manage soil compaction, and particularly in alleviating that compaction through cultivations, probably the first thing and the major thing to consider is, do we really need to alleviate the compaction, as in have we actually got compaction at depth, and also to get a spade out and to have a look in the field just to determine what depth that compaction is at. Quite often you'll be surprised to find that it's at a much shallower depth than you first thought, and therefore you'll need to, or potentially you can use a shallower depth of cultivation, therefore using less draft requirements, reduction in fuel use, and obviously improved timeliness as well. Generally speaking, that obviously the deeper you cultivate, the slower that takes. So that's the first important consideration. Also, what conditions are you going to do it in? It's important to consider obviously the soil moisture, particularly when you're cultivating at depth to alleviate deep-seated compaction. Soil moisture will have a big effect as to whether you're actually doing the right thing in terms of shattering and breaking up that layer of compaction. Rather than under wet conditions, you tend to create a slot, which obviously is going to lead to potentially further compaction and also obviously be a costly operation and therefore unnecessary. So just consider those things. Also consider the time between the carrying out of the subsoil operation and subsequent cultivations and drilling operations, because obviously when you cultivate a soil, particularly with the subsoiling, you're breaking up the structure of the soil to effectively open it up, open the pores up, but that soil becomes quite weakly structured and susceptible to following field operations if done under a short space of time. And work by Tim Chayman with his PhD illustrates this quite nicely. So here we have some results taken looking at soil strength using a penetrometer, and this is the soil strength in megapascals across the top, and this is the depth of the soil profile down the side there, and this line is effectively the soil strength as found in the field. We then carried out the subsoiling operation, and it did a very good job of breaking up the soil and obviously reducing the strength of that soil down to a good low level. However, when we came back with a large tractor for cultivations and a medium tractor on the drill, so effectively 2 operations, we actually increased the soil strength to beyond what it was initially before we did anything to the field. Even when we used a tracked tractor, we had some reduction in strength between 10 and 20 centimetres, but we were still getting much closer to how the soil, with the initial state of that soil before we had subsoiled it. So leaving a window between your subsoiling operation and your subsequent field operations is going to be important to allow that soil to stabilise and settle down. When we consider field traffic, potentially your typical tractor on 750mm tyres, you have 2 of them, that gives you 1.5 metres, and a 3-metre cultivator, you're already covering 50% of that field area in one single pass. So obviously subsequent passes you're doing for cultivations to create a seed bed, or your drilling operation is further passes after that. And we know that those can cause further damage. With a study carried out at Morley with NIAB TAG and Tim Chayman with his PhD thesis, we actually looked at creating a range of trafficking effect from zero traffic, so as an example, a controlled traffic farming approach, through to a compacted system. We also looked at some in between, because obviously if we can get, or there's a suggestion that we can get most of the benefits from taking out the compaction or removing the risk of compaction without going to a full controlled traffic farming approach, then obviously that can be useful. So we looked at a range of trafficking approaches. This is the least amount of traffic, right through to either a tracked or a wheeled full traffic system. And because this was a sort of replicated trial, and to get a consistent effect across the plot, we effectively wheeled everything from one wheeling to the next across the entire plot. But as I said from the previous slide, we know we can quite easily wheel 70% of a field area very easily. So it's probably not too far off from various passes across the field. We can get a similar situation as to this. We then had 2 different tillage approaches, either a shallow or deep tillage approach, and we can see the effect of those trafficking approaches on crop yield. And this is in winter wheat, so we can see a fully compacted plot with only a shallow cultivation gave us about 1.5 tonne yield reduction compared to where we hadn't trafficked at all. Where we had used either a wheeled or a tracked combine, we were able to get much nearer to a zero traffic system, and obviously without going to a no traffic approach. And we were also able, particularly with the tracked machine, where obviously you're spreading the pressure or the weight of that machine over a greater surface area, we could see that we were actually lifting the yields up quite significantly where we'd done a deeper tillage. And that suggests that the compaction was at a much shallower depth, and by doing a deeper cultivation, we'll be able to alleviate that. So it is just important to consider the impacts that cultivations can have on reducing that pressure from soil compaction on crop performance. So just to summarise, we can actually manage soil compaction through a range of different approaches, whether that's through machine settings, tyre pressures, or whether at such systems such as controlled traffic farming. If we are looking to remove compaction at depth, we do need to consider what depth that compaction is at, what are the conditions like for doing those cultivations so as to minimise the potential for creating further compaction at depth, which is going to be difficult to remove, and also how we can minimise field traffic or keep it to set pathways across the field so as we can reduce the loss or reduce the risk of loss of yield, and also target a cultivation depth to alleviate compaction if it's not necessarily as deep as you might first have thought. So I hope this gives just a brief summary as to managing compaction. Thank you very much.